Good afternoon. The second polynomial video is multiplying polynomials. So the main concepts we're going to use here is something we've been using for a long time, the distributive property, and a newer concept which is the simplest form of polynomials. I'll put in parentheses here. Simplest form of polynomials is achieved by combining like terms, and that's something we talked about in the last video. Adding and subtracting polynomials, combining like terms. So you know when a polynomial is in simplest form when all the terms that you could combine are combined. Okay, but you'll see what that looks like in a second. So first, distributive property. What does that have to do with polynomials? Well, if I have a monomial multiplied with a polynomial, I'm going to have to use distributive property because the monomial is a single term, right? And the polynomial is a sum or difference of two or more terms. So if you picture what that looks like, one term times two, or the sum or difference of two or more terms, it's going to look like this. It's going to look something like this. And taking this, distributing that A, and turning it into that, is putting this into polynomial form. Because remember what a polynomial is. It's a sum or difference of two or more terms. Here's a term, here's a term. Therefore, that's a polynomial. This is not a polynomial because this is a product. This is something times something, not a polynomial. Something plus something, that's a polynomial. So here's an example of a monomial. I'm just going to take 2x, simple monomial, and I'm going to multiply it with a binomial of 3x plus 5. Monomial times binomial. So I distribute my 2x times 3x, carefully using my laws of exponents, that's 6x squared, plus the product of 2x and 5, 10x. So I've put this product into polynomial form. Monomial times binomial becomes a new binomial. And to put our vocab to good use, yes, this is a binomial, but it's also a binomial with degree 2, because this term has a higher degree than this term, and the degree of this term is 2. Therefore, the degree of the whole binomial is 2. Now, I can also multiply a monomial with a trinomial. Such as this. The only difference is I'm going to have to distribute that 3x to all three terms. 3x times 4x squared, 12x cubed. 3x times 2x is 6x squared, but remember this is a minus because that was a minus. And then 3x times 1 is 3x. So again, I end up with a polynomial of the same number of terms as the one in the parentheses. And that's because if I multiply by a monomial, that's not going to increase the number of terms in my product. The number of terms in this polynomial will remain the same. So this one's a trinomial, and the degree of it is 3. Okay, one more example with a monomial times a polynomial. I'm going to throw in a second variable. 2xy is now my monomial. Okay, so I'm going to distribute that 2xy here first, multiply the coefficients, 6, and then the x's, x cubed, and then the y's, y squared. Then the second term, 2 times 8, 16, x and x squared, y and y squared, y cubed. And then finally 2 times, don't forget the minus, 2 times 1/2 is 1, so I won't write anything. And then x, y, there are no x's or y's in the third term in the trinomial, so the product is just x, y. So this is again a trinomial, and the degree, so first I need to find the degree of each term. The degree here is 5, the degree here is also 5, the degree here is 2. Therefore the degree of the whole trinomial is 5, because that is the highest one. Okay, now we're going to multiply a binomial with another binomial. So 2 terms with 2 terms. And I'll start with this simple example, x plus 2 times x plus 3. Again, this is not a polynomial. I want to multiply these two so that it turns into polynomial form. And I'm going to write down our distributive property here. Whoops. Okay, so what I want you to do here is picture x plus 2 as a. And then use the distributive property to make this expression behave like that. Behave like a times b plus c becoming ab plus ac. So treat this as one entity. And then treat the x and the 3 in the x plus 3 as 2 entities. So if this is my a, my one entity, I'm going to distribute this one entity with the x and then with the 3. Okay, so first with the x. My one entity, x plus 2, gets multiplied with x. Then plus x plus 2, my one entity, gets multiplied with 3. Okay, the x plus 2 has now been distributed. Now I have 2 new distributive property scenarios. I'm going to distribute the x and then distribute the 3 here. Okay, I end up with 4 terms, which makes sense because I distribute x plus 2 with 2 terms, but then after that I distribute in 2 places something to 2 terms again. 2 times 2 is 4. So I should end up with 4 terms. However, remember at the beginning I said simplest form of polynomials means combining like terms. So I look at all these terms and I identify any like terms, if there are any, and I see 2x and 3x. So to simplify, I must combine them. And I get x squared plus 5x plus 6, a trinomial of degree 2. Okay, so notice what happened. When I had a monomial times a binomial, I got a binomial. 1 term times 2 terms gives me 2 terms. 1 term times 3 terms, 3 terms. 1 term times 3 terms again, 3 terms. When I had two binomials as the factors, 2 terms times 2 terms, I initially got 4 terms. But 2 of those terms happened to be like terms, so I ended up with 3 terms, trinomial. This doesn't happen all the time. Sometimes you will get 4 terms that are not, where there are no like terms, so this would stay a 4-term polynomial. Okay, let's try that again. Different example, a little more complicated. 2x plus 3 times 4x minus 2. Okay, so again, I'm treating this like A, and this B, and this C. So I'm going to distribute the A to the B first, minus, and then distribute the A to the 2. Okay, then I have to distribute in 2 places, here and here. 4x times 2x, 8x squared, 4x times 3, 12x. Now here, I have to be careful. There's a minus here, so I need to put what I get here in parentheses, 4x plus 6. Okay, here I'm just going to distribute the minus so that the parentheses are gone. Okay, so I ended with 4 terms as expected, but these 2 terms, the two middle terms again, are like terms. I get a trinomial of degree 2. Okay, now I want you to notice something in the last 2 examples. This step right here, for some of you, is going to feel unnecessary because you may have noticed something about these 4 terms that we got in the second step. This first term, x squared, is the product of x and x. This term is the product of 2 and x. This term is the product of 3 and x. And then the last term is the product of the 2 and the 3. So the 4 terms are simply the product of every possible pair of these 4 terms, as long as you take one from the first parentheses and one from the other parentheses. Every possible pair is accounted for here. This is x from the first one, x from the second one. This is 2 from the first parentheses and the x from the second. This is the 3 from the second parentheses and the x from the first. And this is the 2 from the first parentheses and the 3 from the second. The same thing happened here. 8x squared is the product of 2x and 4x. 12x is the product of 3 and 4x. Minus 4x is the product of 2x and negative 2, and the minus 6 is the product of the 3 and the minus 2. So it is actually, you can, if you wish, skip this step and go straight to here, if you feel comfortable doing that. If you feel comfortable doing that. And it's also true that since this is all addition and subtraction, you can do this multiplying one from here, in any order you want. You don't have to do it in the order that I did it. So if you feel like doing 2x and negative 2 first, you can do that. If you feel like doing 3 times 4x second, you can do that. And then 3 times negative 2, and then 2x times 4x, you could do that last if you want. you're still going to get the same 4 terms that I have here. And you'll still get the same like terms that you need to combine. But there's one thing you do have to do that you don't have a choice about. When we write polynomials, we usually, 99.9% of the time, write the degree of the highest degree first. The term with the highest degree comes first, the term with the next highest degree comes second, and the term with the lowest degree goes last. So even if you do, so if you get something that's in a different order than this, you can't leave it like that. You still have to change it to highest degree to lowest degree, descending degree. Okay? What I just described, some books and teachers call this process FOIL, because this 8x squared is the product of the first terms, the 2 first terms in the parentheses. Sorry, it would be FOIL if I put it in this order. So this is first, the product of the 2 first terms, minus 4x is the product of the outer terms, because it comes from these 2. 12x comes from these 2, so that's called the inner terms, the product of the inner terms, and then the minus 6 is the product of the last terms. FOIL, FOIL. But as I said, it doesn't matter what order you get these 4 terms in. So it doesn't have to be FOIL, it could be FEAL, or FLEO, or FLOY, or LOIF, it doesn't matter. As long as in the end you put the terms in descending order after you combine like terms. Okay, that's it for multiplying monomials with polynomials and multiplying polynomials with polynomials.